Hello there. Let's talk about PV diagrams. There are 4 PV diagrams you want to learn side by side. So the first one is isochoric or isovolumetric. So that means the same volume. So let's draw 2 cylinders, 2 boxes, same number of moles added, gas moles, and the constant volume V in a box, right? Doesn't change. So P1 T1 goes to P2 T2, the pressure and the temperature. Let's say this is sealed with the piston is sealed with the lid with a clip, metal clip, right? So that means no work. That means W is 0. That's how you can remember. So piston is locked, no work done. So delta E internal energy is Q plus W. The W is 0. Delta E is Q. Now we can also write delta E is NCV delta T. CV is for the constant volume. That we can discuss in a different question, but that's also valid for this situation. So PV diagram, the y-axis is P, and then this is the constant volume, right? Let's say A to the B states and 2 liters constant volume, right? W is 0, volumetric, no work done, 0 W. Okay, now, so let's move to the next situation is isobaric. That is the constant pressure. Iso is same, constant, and the pressure, right? Now, this one we can think, where do we have this situation? And also it's the planet Earth, right? Here's me on the planet Earth doing some experiments. Nothing is 0 here. Nothing is free on the planet of Earth, right? So think that way. So nothing's going to be 0. Now let's look at the 2 states of the gas samples. So first one goes to the A goes to the B, constant pressure, 1 atmospheric pressure on the surface of the Earth, 1 atm, and V1 T1 goes to V2 T2. That's the volume and the temperature change, right? Let's say both are increased, right? We know it's a linear relationship and it's proportional, right? So the delta E again is equal to Q plus W. Internal energy is heat Q and plus W work, right? Now, so we can also write few other formulas here, and let's see, NCP, Q is NCP delta T, Q is actually delta H. Oh, I need to draw the PV diagram, so let's change this one. The delta H will come later anyway. So the more important thing is actually looking at the PV diagrams, the graph. So the delta E is Q plus W, Q is NCP delta T, which is also delta H, right? That's correct. So pressure over and volume versus, and you get the same pressure, 1 atm, right? So the same number of moles A to B going into the A, from A to the B, and these are the formulas you can use, right? So isochoric, isobaric, same volume, same pressure. So the 2 different situations, right? Now let's look at the third one, which is isotherm. So the isotherm, the same temperature, iso same, therm temperature, isotherm. So the isotherm, we have, let's say the gas sample A goes to gas sample B, right? And A goes to B, and you have same number of N number of moles, gas moles, and the T is constant, isotherm. And the P1 V1 goes to P2 V2, right? Okay, now so this is the magic part here, right? So delta E is 0. Internal energy does not change. Okay, the change does not have a value, but there is internal energy though, right? The delta E is 0. So if the delta E is 0, K plus W, and 0 is Q plus W again, and the minus W is Q. If you want the other way, times by minus 1, you get W is minus Q. So both are correct. You can use it as you need. Remember, energy has a value, but delta E has 0 value. Now, so the PV diagram, the more important things, pressure versus volume. This is basically the Boyle's law, right? T1, it's one isotherm, T2 is another isotherm, T3 is another isotherm. So we can draw different isotherms here, different temperatures, 20, 30, 40, likewise. So that's the isotherm, and what's the formulas. And the last one is adiabatic. So the adiabatic one is actually what's happening. The Q is 0. You do it carefully so there is no heat loss or gain. That's the 0 here. Now A to B, 2 stages, same number of moles of gas in N. So the question is, not everything is changed. P1, V1, T1 is changed to P2, V2, T2, right? So that means delta E is Q plus W. Q goes to 0 because we don't let loose heat. So delta is equal to W then, right? Now we know delta is E also same as NCV delta T. Okay, W, it can be written in a different way too. So we'll focus on this later. We'll look at the PV diagram. The graph is more important actually at this point. So let's put the graph here. The graph is P versus V, and we have, let's draw two isotherms, let's say 20 degrees and 30 degrees for each sample, T1 and T2. The transition happens between the two, so that's why everything is changed. So the compare all four side by side, that's the best way to do it. Thank you.